So today we're going to be looking at different kinds of stellar objects. And we're going to start off with something called a pulsar. Now, a pulsar is simply a rapidly rotating neutron star. And we came across neutron stars in our formation of stars video. Now, neutron stars are how some really massive stars can end up at the end of their life cycle. And what a pulsar is it's a rapidly rotating neutron star. And because of this rapid rotation, it can actually exhibit magnetic poles. Now, because of this rapid rotation, it can emit regular bursts of EM radiation. In other words, it can emit pulses, hence why it's called a pulsar. So if you were to point in the direction of a neutron star, you would see at regular time intervals different signals coming from that star. Now we also looked at how some massive stars can end up as black holes. Now a black hole is a very dense object that has such a strong gravitational field that even light cannot escape. So if we were to look at a mass orbiting a black hole, and this mass was a distance r from that black hole, in order for this mass to not get sucked in by this black hole, we would need that the kinetic energy of the mass is greater than the potential energy exerted by that black hole. And this means that a half mv squared must be greater than gmm over r. We can get that the radius of this object must be greater than 2gm over v squared, where v is the velocity that this object is moving at. So in order to get sucked in, it must be at a distance greater than r here, where r is 2gm over v squared. Now the fastest possible object that we know is light. So the minimum distance that you can stay from a black hole without getting sucked in is given by Rs equals 2gm over c squared, where c is the speed of light. So only light that is a distance greater than 2gm over c squared can escape from the black hole. Now, staying on the topic of black holes, scientists have theorized that at the center of every galaxy there is a supermassive black hole. So this is my representation of a galaxy. This is the center of this galaxy. And if I have an active galaxy, I can call this an active galactic nucleus. In an atom, a nucleus is the center of the atom, same way that this active galactic nucleus is the center of this galaxy. It's strongly believed that the galactic nucleus is a supermassive black hole. I'm going to introduce you to a special kind of active galactic nuclei called quasars. Now, as matter circulates this active galactic nucleus, it forms something called an accretion disk. So this here is my accretion disk surrounding the quasar. Basically, there's going to be a lot of energy and a lot of heat, and due to friction between the matter in this accretion disk, what you're actually going to get is massive amounts of energy being shot out from either side of this active galactic nucleus. Now, I'd recommend you go and Google an image of a quasar. Some of the generated images can look pretty sick. What's special about quasars are that these are the furthest detectable objects in our universe, and that is because they emit such great amount of energy that we can detect them from so far away. So these could potentially emit the amount of energy equivalent to hundreds of galaxies put together. And it's because of this massive amount of energy that these quasars can be detected from so far away. Now, the best piece of advice I can give you after watching that video is to go off and practice on past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.